In this video, I will show how to find an integral of a simple rational function that cannot be decomposed using the partial fraction decomposition. So first step is to recognize that we have a irreducible quadratic term in the denominator. So here, if we find the discriminant of this quadratic expression, we'll learn that it is less than 0. So if this quadratic term is irreducible, that means we have to complete the square to obtain the following expression. So we're going to have x minus 1 squared plus 1. Now, in the numerator, instead of x plus 3, we want to have x plus 1. So I'm going to break that 3 into plus 1 and plus 2. Why do we want that? Because now we can split this fraction and the integral into two integrals. And actually, we want to have x minus 1 here, not x plus 1. So x minus 1 plus 4. And here's what we get after splitting the integral into two. And for both of these integrals, we're going to do the substitution t equals x minus 1. Now, the first integral can be done by another substitution. So let's let s be equal t squared plus 1. Then ds will be 2t dt, and t dt then is equal to 1/2 ds. So after doing this substitution, we get the following integral. We have 1/2 ds over s, and the second integral is actually something that we should know. It's the arctangent of t. So now the antiderivative of the first one is ln of s, but s is t squared plus 1. So this is the antiderivative for the first one, and for the second one it's arctangent of t plus c. And now instead of t, we plug in the original variable x, so we have ln of x minus 1 squared plus 1, which is x squared minus 2x plus 2 plus 4 arctan t. T is just x minus 1 plus c. So the same way we can integrate any rational function that looks like this. When the quadratic expression in the denominator is irreducible.